Hello, so today we are doing this problem called binary tree right side view. And so the problem says that we get a binary tree, and we can imagine ourselves standing on the right side of it, and when we return the values of the nodes we can see ordered from top to bottom. So for example, for this tree here, if we stand like on the right, like these are rows over here, what we can see are 1, 3, 4. So basically you can see that it's just the rightmost value of each level in the tree. And so how can this problem be solved? So you can already see that I said right level side of I said like the first value of the last value of each level. So whenever there is a traversal that does each level, we can directly think about doing BFS and doing level by level traversal. But also, even if we do just DFS, we can think here that even if we do DFS, like what we can do is just record for each level. Let's say for level 0, we have 1, and then for level the second level we can have 2, and then keep updating it. Or we can do something different with DFS, right? We can do DFS, but instead of going left first, we go right first, then go left. That way, what do we have? So if we go always right first, that means that we will always get the rightmost value of each level first, right? So this means that we will get always the rightmost value for each depth first. Depth, level, whatever you want, first. And so we can just have an array. That way we can just have some array like result, and we can index it by level and update it only once. And so update only once, because once it's updated, that means that was the rightmost value, since we will go right first always. And then when we go to the next element, it's already updated, so we will not put a value in it before. And to be able to do update only once, we can just check that the length of the result is less than level. That means that we haven't yet added this level. And so if that's the case, then we can just take our result and append the value that we want. And so yeah, so that's how we can do it with DFS. So let's get right into it and do it. So we can do first like DFS iteratively with a stack. So let's see how can we code this up. Okay, so the way we can do DFS with a stack is we need first to have like the rightmost. So let's just call this our result, which contains the rightmost values. We can say stack, start with the stack, that will contain the root and the level, like the node and the level. So we would have root, and the first level is 0. And well, if we have an element in the stack, we will pop from the stack. That will give us node and level. And then we would update only if res doesn't contain that level yet. So we'll check if length of res is less than level, then update, which means append node.val, which is what we said here. And then after that, we need to go right first, so that the first value is always the rightmost one. And so we will need to append. So for a stack, in order to go right first, that means we need to put left first and then put right, because if this is a stack, then we want the rightmost value to be on top, so when we pop, it can be the first value popped. And so to do that, we need to add it last. That's how stack works. So we need to say append node left first, and then append right, so that it can, and then we append right. But also we need to add the level. Our stack needs the level so that it can check this. And so the level for each node is just the current level plus 1 because we are going one level down. And then after that we add the right. So this way we can have the right value added last so that it can be on top, so that it can be popped first, right? And then at the end we can just return our result, right? So let's run this and see. So we didn't check node. So a quick way to do that is just to check here if so we need to check that the node we have is actually a value. So let's actually do it here. Okay, so we are missing a value because the length first starts out as 0, and since level is 0, we want to add it. So let's do level equal. Okay, let's see, can we try something else? Okay, let's just submit and see. Well, we can try something. Let's say we can try, let's put 6, 2, 1, no, 5, something like this. So that would give us a tree like this. Let's run this. So that one works. Now let's try an empty one. Okay, so yeah, Leetcode doesn't handle it, but we do handle it correctly, and so let's submit. So that passes. That was a DFS solution. Now we can do the same thing with BFS. As I said earlier, we can instead of doing the DFS that we did, we can just go level by level and add the last value, because that's BFS. Add always the last value. That would be the rightmost value of each level. And so we can do that either by doing a couple of things. So one way to do that would be, let me just delete this, just this part here. And so for BFS, go level by level and take the rightmost value, right? Which is the last value of the level, one thing we can think of is we can either check the same way, check the length of our result. If it's less than some level plus minus 1 or something, like if we know that it has the last value, then we can put it, but we don't need to, because with BFS, since it's the last value, we can just keep updating, and the last value will take over, because that will be the last value of the level. And so basically we can just keep updating. So let me do that for BFS here. So for BFS we need a queue, and then we need, so let's just define our queue here, which would be collections.dq. Note that I'm using a DQ here instead of a list, because I need a pop and append in a constant, with constant time. But with a list, the pop would be, to pop the first element, we need to go and traverse the list, so that would be a no-event operation. And so okay, so we need to go and do while queue. Then we need to add first the start value to the queue, and so that means let me just fix this quickly. Yeah, my computer is slowing down because of OBS. Let me try to shut some things down. Yeah, okay, let's just leave it like that and just try to continue. Okay, so for BFS, okay, so while queue, we can, so first we need to add the start value, so that would be the root and the level, right? Which is 0 first. And then we need to have a node and the level, and those would be popping the right most value of the queue. And then after that we need to go left and then right to just traverse level by level. And so basically what we need is to have also the res result. Let's call it res, and let's set it to be, let's just use a dictionary here so that it becomes easier. Let's just call it dig. And then what we are going to do is that we are going to say res of depth or level is going to be equal to node.val, and we are going to append the left and the right values for the queue. That's what BFS does. And so the next one is level +1, and then we do the same thing for the right node, and we return res, right? And then, yeah, so with this here, level is, so here we can just say it starts out as default and then it gets updated. That is with, well, let's just keep it dict and see. And so we return the result, and here we will keep updating for each level until the last value, and the last value is the rightmost, which is what we want. And so yeah, that's about it. Let's run this. Yep, so we have, yeah, so yeah, what we want here is we have okay, let's just give it a default dict with value int. And let's see. Yep, it's DQ like this. DQ like that. Okay, so same thing, we need to check node. Okay, let's try to put one of the 3 examples that we have here. Okay, which is this one. Okay, seems like we have a problem here. We are adding 0, 1, 2 instead of 1, 3, 4. Let's see, why is that? So we are adding the 1, 2, 3, 0, 1, 2, which basically are not the values we are looking for. Yep, so basically that's because of the way I'm setting up my default DQ. So how can we fix that? So let's just say, let's keep track of a max depth so that we can know where we are at, right? And so okay, so this, let's take max depth here, and let's say this value starts out as 1, -1, so that we can always replace it. And here, let's update with, or let's call this max level. Basically, it's to know the last level number. And here, this would be max level, and then level. And with that, actually, because this one may be null, so let's just add it here, and that way we can say the current level is equal to node value, and we would have a map, and now we can get the values of the map instead. And the way we are going to get these is by doing res level 4, because that's where we have the value instead of the indexes that I just returned. And so that would be for level in range of the max depth, because that's the, or max level, because that's the levels that we have. And we need to do +1 because we are starting out at -1. And so, and also for range, if we do range of 1, it will just return 0. If we do range of 2, it will just return 0 and 1. But for us, when we get to max level 2, we want 0, 1, 2, and so this to get around that. And so let's try this. Okay, so this now works. So basically, earlier the problem was that I was returning res, which is a map, but what I need is the values of the map. And so now I'm just getting these values by keeping track of max level, so I know what to go through. And yeah, that's pretty much it. So let's submit. Okay, let's save that passed. Yep, so that passed. So yeah, that's it, solving it using BFS and DFS. So the nice thing to learn from this problem is that we don't have to always follow the same order of adding left first and then right first. For example, in the DFS solution, we added right first and then added left after that. Here also we might have another problem where with BFS, it may require us to add right first and then add left after that. And so, yeah, whatever traversals that works for us that will solve the problem, we can do. And it will still be BFS because we are still going level by level, or it will still be DFS when we are going all the way down. And so that's the nice insight for this problem. Yeah, that's it for now, and sorry about the glitch earlier with OBS. Yeah, see you next time. Bye.